type of problem that we will go over is molar volume and combine it with molecular formulas and empirical formulas. So these are always the toughest problems because they combine old concepts with gas laws. So if you remember from older videos or older chapters that you've covered in your course, one thing is that a compound can be labeled as percents, meaning that we can figure out exactly what the chemical makeup is, but we don't know what the molecular formula is. So I have a compound here that's made of 24.018% mass carbon and 75.982% fluorine. Now, with percents, that can give us the empirical formula, which was the simplest ratio of your molecular formula. It's not the true identity, but it gives you the simplest ratio. Now, if you have 1.55 grams of your compound and it occupies 0.174 liters at STP, what is the molecular formula? Now, the bottom piece of information, what that tells us is it gives us an identity of what the molecule is. So we can actually figure out what the molecular mass is from that, but we can't figure out what the actual formula is. So with the percents, you can figure out the formula for the empirical, and down here you can find out what your molecular mass is. So if you kind of remember back, flip through your notes, you'll see, oh crap, that is actually setting you up for your problem. Let's go through the steps of how to do this kind of problem first before we go through it. And if you'd like to write them down as you go through it, it'll help you be able to follow along with this video. If this is your first time seeing empirical formula problems, I would recommend my empirical formula video to help you be able to do that. And you can see the link is below in the about section of the video. So the first thing we have to do is we need to find and set up the problem like an empirical formula problem, meaning this is where we're going to use our gas laws. So in the problem here, it's at STP, meaning we're going to use the molar volume. It's going to be an easier problem. But sometimes you have to use the ideal gas law to find that. So it allows you to find the number of moles, which you can then plug into the mass. So mass divided by moles is your molar mass. So if you're given a mass in a problem and all of the different ideal gas values, you're going to have to go through these steps. So that will give us our molar mass. Now from there, what we will do is go through our steps of an empirical formula problem. The first thing is being that you were given percents, remember the word percent out of 100. So what we assume is 100-gram sample or percents of our empirical formula. So we will convert those to grams. Then our goal is always the mole, meaning we will go from gram to mole of each of our units. So we had carbon and fluorine in this problem. We will convert both of those to moles. And what you're going to see is there's going to be a mole to mole ratio between them. And being with molecules, we're always interested in what the smallest ratio is because that illustrates what the true percentage is. So whichever is the smaller of the two, you'll divide both by that. And then that will give you your different subscripts for your values. So let's say if we were to divide that and if we had some kind of species, we'll just say from there we had AB3 was, let's say, our subscripts. So it's like, well, what would I do from there? Well, if that's your empirical formula, this is where you'd go on to the next part. So step 5 is optional depending on what you were given in the problem. In this case, you had the gas law information, so you have to continue, right? You're not done. Oh, sad days, right? You have to keep going. So if that's the case, well, depending on being that you have this problem, you found the molar mass from part 1. So what you'll do is with that, let's say that AB3 molecule, you'll find the empirical mass. And now you will divide the two. So when you divide the bigger one, which is the molecular mass, by the empirical, you're going to gain a ratio. So now the purpose of that whole number ratio, so if you get a decimal, that means you divided it wrong. You got to flip the two numbers. This is going to be the number that you're going to use to multiply your empirical formula by. So let's say if I had AB3 from earlier and I got a ratio of 3, you would multiply that formula by 3 to then get A3B9, which could be your hypothetical molecular formula, which should match your gas law molar mass. All right, so this is what we're going to go through in this problem. It looks a little complicated right now, but I would recommend writing these steps down for yourself. So if you want to pause it, rewind, and write them down, then it'll help you be able to follow along with the video, especially if you're trying to do this for yourself to learn how to do it for, let's say, your homework or for an exam. And this is a common problem that you can see maybe in introductory chemistry or in general chemistry. Let's take a look at how we do it. So let's start with actually just finding what our molecular formula is. And then we can kind of put this guy in a normal empirical formula problem. So using our gas laws first. So earlier, we did this step where we found out what the moles were for using the ideal gas law. We could still do that here. But there's another ratio that's important to know when you are at STP. So when we are there, what that means is that 22.4 liters of any gas is equivalent to 1 mole at STP. Okay, so being that this problem is here, that makes the problem faster and easier. So being that we have 0.174 liters here, we can convert this to moles using this value. So what we'll do is we'll put 22.4 liters on the bottom. That's equivalent to 1 mole. And we will use this to cancel out our liters. And we will have how many moles are in this molecular formula. So when we do that, we will get 0.077,678 moles of our unknown gas, and we're not sure what it is. Now to figure out our molar mass, well, if you keep in mind, we got to do grams divided by moles. So we were given 1.55 grams earlier. So let's find out what our molar mass is. So what I'm going to do is I'm going to take that 1.55 grams, and then I'm going to divide it by the number of moles that we just obtained. Okay, so we'll put that down here. We'll divide those two values. And what that's going to give us is our molar mass. So by doing these and combining them together, you'll get 199.54 grams per mole. So this is your molecular mass. So great. Now what? We're not done, unfortunately. There's a little bit more. And this is taking stuff that we went over during moles, right? So taking that concept of empirical formulas, empirical masses, which are your ratios. So if we find the empirical formula, we can find what its molar mass is and then divide it into this guy to figure out, well, what's the ratio that you need to multiply it by to get your formula. All right. So earlier we were given this bit of information about the mass and of carbon and fluorine. We can use this to do our next step. We can assume that this is a 100 gram out of 100 grams. So we'll take 24.018, and we will also take our mass of fluorine as well. So we'll color code. So we have 24.018 or 75.982 grams of fluorine. We have our number for carbon, and we are going to convert them both to moles. So now when we do that, we're then going to divide them both by the lowest number of moles. They're the least common multiple of the two. So we know that the molar mass of carbon is 1 mole. That's 12.011 grams of carbon from your periodic table. We have fluorine, which is 1 mole of fluorine, equivalent to 18.998 grams of fluorine. And when you solve for both of these, you'll get 1.999 moles of carbon and then 3.999 moles of fluorine. So now what? We got to divide by what the least common multiple is. So what's the smallest of the two? We're going to divide by carbon because it's smaller. So when we divide both of these by 1.999, we're going to get our empirical formula, which is going to be C1F2. Now, what we can do with this value is figure out what the empirical mass is, because we want to divide it into that molar mass that we had earlier. So in order to find that, we will take that 12.011 grams per mole, then add that times the molar mass of fluorine. And what we are going to get is a molar mass of 50.07 grams per mole. We're going to take this and divide it into the mass we had earlier. So we had 199.54, and we will divide 50.07 into that number. And this is going to be the ratio, which is 4. So we'll take 4 times it by CF2, and your final molecular formula is going to be C4F8. And that's how you can combine moles, empirical formulas, gas laws, and put everything together, right? So this is probably the hardest problem you could ever have when it comes to these, because it combines old concepts with new concepts and helps you be able to figure out exactly how to figure out all these hidden steps. I hope this video helped. I know it was a longer one, but it goes through all the tips and tricks of how to solve those really hard gas law problems. Thank you so much for listening, and I hope to all see you in the future. And if you haven't yet, please hit that like and subscribe button, and please check out my other videos on gas laws to help you fully master your understanding of this concept. Also, feel free to go to the empirical formula video to understand this part as well. Thank you all, and I'll see you all later. Bye now.